curious, observant. We are watching a massive migration in the technology sector. Artificial intelligence is graduating from the low-stakes world of casual chatbots and integrating directly into weight-bearing enterprise workflows, like autonomous agents and legal review. A casual conversation can easily tolerate loose reasoning, but high-consequence corporate environments operate on different physics. In a boardroom or a compliance audit, plausibility is not enough to survive. This exposes a recurring failure in current enterprise AI. Large language models frequently generate highly fluent text that describes the value of a business strategy perfectly, but they completely fail to identify the underlying mechanism that actually creates that value. When you deploy that kind of fluent, unstructured generation into a high-stakes arena, a hallucination is no longer a harmless quirk. It becomes a direct driver of massive financial cost, legal liability, and operational collapse. If a venture capitalist or an enterprise buyer reads an AI-generated proposal that promises massive returns, without showing the exact structural conversion of resources to capability, they stop reading. The failure to identify that mechanism renders the strategy entirely uninvestable. Left unchecked, these unsupported claims trigger a cascade of secondary risks. Teams experience institutional drift. Contradictions quietly embed themselves into operations, and what started as a seemingly intelligent output rapidly becomes a serious reputational and business liability. The market demand here is explicit. Corporate buyers have no use for more persuasive text. They require structurally reliable work that can survive a brutal, line-by-line audit by decision-makers, lawyers, and engineers. This chart plotting AI deployment depth against the cost of uncontrolled generation shows exactly why. As AI integrates deeper into high-value workflows, the financial risk of a generated mistake becomes sharply exponential. To survive this mounting pressure, prompt engineering and style checkers are insufficient. AI requires an entirely new operating capability to guarantee its output. This structural gap is solved by a specific capability, EP function 06, known as mechanism identification. This function operates as a core component of the AI's architecture. It replaces surface-level tone checks and post-generation editing with an active structural control that governs the logic before the output ever appears. As this flowchart shows, it is a core operating function. It acts as a rigid gateway that intercepts the raw data. It changes how a task is framed before the answer is produced, how the logic is checked during generation, and how the final result is judged. The primary objective of this gateway is precise. It hunts for the exact mechanism that converts raw resources into capability, forcing any unsupported claims to be backed by verifiable evidence. By implementing this filter, the system stops relying on ordinary associative generation and enters a highly disciplined environment of deductive, controlled work. Explaining a function in a document is easy. Its actual value is proven only when it performs repeatedly under the heavy pressure of real enterprise tasks. Mechanism identification forces 4 rigid constraints onto every single generated claim. What changes, through what specific process, under what constraint, and with what measurable result. It takes a chaotic cloud of floating information and organizes it into a tightly locked, rigid block. Apply this to a business proposal. The system strips away all the fluent, persuasive language and drops this rigid block into the framework, instantly revealing its core structure. Drop that exact same block into a legal agreement, and it immediately stress tests the logic, exposing a hidden contradiction in the terms before it can cause a downstream failure. When an AI output fails this structural test, the system captures that failure, classifies it as an operational error, and feeds it back into the loop to refine the next execution. This is true execution traction. The mechanism identification function brings the AI's reasoning path out of the black box, verifying the logic against structural requirements and making it entirely inspectable for human oversight. Fixing a single document is incredibly useful, but to protect an entire enterprise infrastructure, this macro logic has to scale. Scalability in the EP framework is the preservation of core operating logic across diverse task pressures. It avoids the pitfall of uncontrolled expansion by focusing on a single structural discipline that applies everywhere. Because structural failure is a universal problem across all complex AI work, The mechanism identification function can be highly standardized and templated. Notice how this central structural hub branches out. You can convert this logic into mechanism libraries, software modules, automated quality gates, and enterprise copilots. The outputs slot perfectly into distinct vertical domains like business models, workflows, and technical strategy. Highly scalable enterprise value does not come from isolated consulting tricks. It comes from standardizing a repeatable mechanism and turning it into a deployable product ecosystem. For an enterprise investor, this specific capability represents the threshold where an interesting piece of technology becomes a highly fundable solution. It satisfies the complete due diligence triad. It connects a severe market pain point in demand to a rigorously executable method and proves its scalability through a repeatable product logic. Evaluating a system like this requires discarding the lens of a simple content tool. This must be evaluated as the required infrastructure for running reliable AI operations. Mechanism identification earns its valuation because it takes a recurring, critical AI failure and engineers it into a repeatable capability. It provides the exact structural integrity that high-stakes environments demand.